Hi, in this video we will talk about the principle of conservation of charges. The conservation of charges is one of the important concepts in electrostatics. When we speak of conservation of charges, it means that the charge in an object can neither be created nor destroyed, which means the total charge of an isolated system will remain constant. In any changing process, charges are merely transferred from one body to another. So the charges can either be positive or negative. So the charges that are present in the objects are neither created nor destroyed. Instead, there are only transfer of charges from one object to another. So when a sphere with an initial charge of q sub 0, where Q is used to represent the charge of an object, is brought in contact with an identically charged sphere, they equally share the total charge. So again, they will equally share the total charge if your objects are identical, if the spheres are identical. If the spheres are not identical, they share the total charge according to their radii, which is the quantity of charge with the quantity of charge directly proportional to that of the radii. And this experiment, the the charged sphere experiment was conducted by Coulomb. So let's have here an example. A metal sphere A has a charge of positive 12 coulombs. It is brought in contact with the neutral metal sphere B and then separated. Find the final charges on the spheres A and B if situation A or question A, if the spheres have equal radius, and B, if the sphere B is twice the radius of sphere A. So let's identify the different given values in this problem. So what are our given values here? First, we have our sphere A, and sphere A having a charge of positive 12 coulombs, and sphere B, since it's neutral, then therefore it's considered to have a charge of 0. So again, you have Q0A, it's equal to positive 12, and QB, which is 0 coulombs, since it's again neutral. For A, we need to solve for the final charge if the radius of A is equal to the radius of B, since again, they are considered to be identical. Now, according to the conservation of charges, if the radius of the objects of the spheres are identical, then therefore they will just share the total charges. So let's look into it mathematically. Since RA is equal to RB, your radius is proportionate to the charges that is possessed by our objects. So we can express it as QA over RA is equal to QB over RB. Now, since RA is equal to RB, then we can express both radii as RA. So we have this one as QA over RA is equal to QB over RB. So we can, QB over RA. We can also express it that way, since again, RB is equal to RA. Now, when we get rid of all the denominators, if we transform this equation, then this equation becomes QA RA equals QB RA. if we transpose these two. So you get this equation. Now, since we have here RA is equal to RA, we can actually get rid of that. And you will have QA is equal to QB. So therefore, the charge for A is equal to charge for B, which proves our claim based on the statement earlier in the conservation of charges that they will share the charge. Now, since they have shared the charge, remember that the total charge is 12. Therefore, QA plus QB is equal to 12 coulombs. Since you have positive 12 and 0, therefore the total charge of that system, of that isolated system, is positive 12 coulombs. Since QB is equal to QA, as we have established, QA plus QA is equal to positive 12C, which is 2QA is equal to positive 12 coulombs. Therefore, QA is equal to positive 6 coulombs. Since we just transpose it there, then we will have positive 12 coulombs divided by 2. Then we get QA is equal to positive 6 coulombs. And since QA is equal to QB, then QB is also positive 6 coulombs. Therefore, if our radii of the spheres are equal, then they will share the total charge of the isolated system, which is positive 12. So you have sphere A will have positive 6 coulombs and sphere B with positive 6 coulombs. Now, what about if sphere B is twice the radius of sphere A? We still have the same given values. Our initial charges for our initial charge for QA is positive 12 coulomb, and your initial charge for QB or sphere B is 0 coulombs. Now it's still proportionate to the radius is still proportional to the charge of the sphere. So again, it's QA over RA is equal to QB over RB. Now we cannot establish that RA is equal to RB because as stated, sphere B is equal to sphere B is twice the radius of sphere A, which means that the radius of B is twice the radius of sphere A, and we can express that in an equation where RB is equal to 2RA. Now, we can change this one into an expression RA, then you will get the equation QA over RA is equal to QB over 2RA. And if we transpose these two here, our equation will become 2QARA is equal to QBRA. Canceling both the RA on both sides of our equation, then we are left with an equation 2QA equals QB. Now, since the total charge of the system, of the isolated system, is still QA plus QB is equal to 12, positive 12 coulombs, then if we substitute, we have established that QB is equal to 2QA. If we substitute that here, then we get QA plus 2QA equals positive 12 coulombs. And that's 3 QA equals positive 12 coulombs. Therefore, QA is equal to positive 12 coulombs over 3, which will give you a value of positive 4 coulombs. Therefore, QA is equal to positive 4 coulombs. Now, if QB is equal to 2 QA, then therefore QB will be 2 times positive 4 coulombs. Then QB is positive 8 coulombs, which still proves the conservation of charges, where the total charges or the total charge in an isolated system will be equal. You have the total charge before interaction at positive 12 coulombs, and the total charge after interaction, you have still positive 12 coulombs. So that's it for our lesson on conservation of charges. Thank you very much for listening.